No one tells you the most unsettling part at first. Not about the stones, not about the weight, not even about the age. The most disturbing thing about Baalbek is the silence. You feel it before you understand it. The road into the Beka Valley is unremarkable. Vineyards stretch toward the horizon. Dust hangs lightly in the air. Vendors sell fruit from wooden stands that haven't changed in decades. Children run between cars. Life moves slowly here, guided by the sun, by seasons, by habits older than memory. Nothing prepares you for what comes next. Because then, without warning, the ground itself seems to rise. Columns explode out of the earth like frozen lightning bolts. Stone so massive it makes the sky feel smaller. Structures that look Roman at first glance, but only if you don't look too closely. Only if you don't ask what they're standing on. Most visitors never do. They point their cameras upward. They photograph the Temple of Jupiter. They admire the scale, the symmetry, the drama. 6 colossal columns remain, each more than 20 meters tall, each weighing hundreds of tons, standing defiantly against time, war, and earthquakes. It's impressive, but it's not the mystery. The mystery is underneath. Hidden below the Roman grandeur lies something older, something heavier, something that shouldn't exist at all. 3 stones, placed side by side, each one nearly 20 meters long, 4 meters high, 3.5 meters deep, each one weighing approximately 800 tons, not together, each. 800 tons is not an abstract number. It's heavier than a fully loaded Boeing 747, heavier than tanks, heavier than anything most modern cranes are designed to lift under real-world conditions. And these stones are not roughly stacked. They are not wedged into place with filler or mortar. They are precision cut. So precise that even today, engineers struggle to explain how the contact surfaces were achieved. The seams are so tight, you cannot slide a piece of paper between them. Millimeter-level tolerances across surfaces larger than most apartments. No glue, no cement, just stone locked against stone. Archaeologists call them the trilithon. Engineers call them impossible. And that's where the story begins. Because Rome did not build these stones. That isn't speculation anymore. It isn't fringe theory. It isn't internet fantasy. It's math. It's physics. It's material science. Roman engineers were brilliant. No one disputes that. They built aqueducts that still function, roads that still carry traffic, domes that remain architectural marvels even by modern standards. But Rome's largest confirmed stone blocks weigh around 50 tons. 50. The trilithon stones are 16 times heavier. There is no Roman crane design, no pulley system, no ramp theory, no written record, no archaeological trace that even suggests the Romans possessed the capability to move, lift, and place stones of this size with this precision. And here's the detail that should make you uncomfortable. The Romans didn't even try. They built on top of the platform. They treated the trilithon as a foundation that already existed, as if it was simply there. Half a kilometer away, carved directly into the hillside, lies the quarry. And this is where denial becomes impossible, because the stones didn't fall from the sky. They were cut. Still embedded in the bedrock are 3 unfinished megaliths, frozen mid-extraction. Tool marks etched into their surfaces like fingerprints left by a vanished hand. The largest is known as the Stone of the Pregnant Woman. Estimated weight, 1,000 tons. Next to it lies something even larger, discovered only recently. Estimated weight, 1,650 tons. Let that number sink in. No structure at Baalbek uses a stone that large. No structure anywhere in the ancient world needed one. And yet, someone was cutting it anyway. Why? And then the most chilling question of all: why did they stop? There is no sign of catastrophe in the quarry, no earthquake damage, no flood debris, no structural flaws in the stone that would justify abandoning it. The work simply ends, as if the builders put their tools down and walked away, as if they expected to return. They never did. For nearly 2,000 years, Baalbek defied explanation. Scholars argued, engineers speculated, legends grew. Locals spoke of giants. Ancient texts whispered of beings who were not quite human. But nothing moved the conversation forward, until machines learned to see what humans couldn't. And that's when Baalbek stopped being an archaeological mystery and started looking like a warning. If this kind of content fascinates you, ancient technology, lost civilizations, and the uncomfortable questions AI is beginning to ask about our past, make sure you subscribe to the channel and leave a like. It helps more than you realize, and it ensures you don't miss what comes next. Because what the data revealed next didn't just challenge history, it threatened it. The shift didn't happen all at once. There was no dramatic announcement, no press conference, no headline that said, "Everything you know is wrong." It began quietly, the way truly disruptive things usually do. A proposal, a budget request, a collaboration agreement buried inside academic paperwork. In the late 2010s, the Lebanese Directorate General of Antiquities approved something Baalbek had never seen before: a full-spectrum digital survey. Not just photographs, not just measurements, a complete capture of the site at a level of detail no human team could ever process alone. They brought in LIDAR scanners, ground-penetrating radar, high-resolution photogrammetry, thermal imaging, and, crucially, machine learning systems trained to detect patterns humans miss. The goal was not to solve the mystery. Officially, it was far more modest: documentation and preservation. That's the language you use when you're afraid of what the answers might be. LIDAR works by firing millions of laser pulses per second and measuring how long they take to return. Each pulse becomes a data point. Together, they form a three-dimensional cloud so precise it can capture surface variations smaller than a millimeter. Every scratch, every cut, every deviation from flatness. When the scanners swept across the trilithon stones, the data sets exploded in size. Terabytes poured in. More raw information about Baalbek than had been collected in the previous 2,000 years combined. And then the AI began comparing. It had been trained on known ancient construction sites across Europe, North Africa, and the Middle East. Roman quarries, Egyptian limestone pits, Greek marble works, even prehistoric megalithic sites like Stonehenge and Karnak. The system knew what bronze chisels look like in stone. It knew iron tools. It knew wedge and feather fractures. It knew hammer dressing. It knew polishing by abrasion. What it didn't know was Baalbek, because Baalbek didn't match. The quarry showed multiple tool signatures, layered over each other like different handwriting styles in the same sentence. Some cuts were consistent with Roman-era tools. That wasn't surprising. Rome absolutely worked the site. But beneath those were older marks, different marks, cuts that displayed a regularity that bordered on mechanical. Parallel striations so consistent they looked programmed rather than struck. Surface finishes that suggested prolonged, even contact across meters of stone, something hand tools simply cannot achieve without leaving variability. Then came the thermal anomaly. At microscopic levels, limestone records stress. Changes in crystal structure reveal whether stone was fractured by impact, pressure, or heat. Several sections of the trilithon and quarry blocks showed signs of localized thermal alteration. Not burning, not fire damage, friction-induced heat Sustained, controlled, repeated. That alone raised alarms. Hand chisels don't generate enough heat over large surfaces to alter limestone at the molecular level. Not even with thousands of strikes. Not even over years. Something else had been used. The AI flagged the data. Unknown tool signature. That was the first moment the room went quiet. Next came the contact surfaces. Where one 800-ton stone meets another, the AI measured deviation from perfect flatness. Across several square meters, the average variance was less than half a millimeter. To put that in perspective, modern construction companies achieve those tolerances using laser levels, computer-guided milling, and vibration-damped cutting platforms. Ancient Rome had none of that. Yet the stones fit perfectly. The research team did what engineers always do when confronted with something impossible. They tried to break it. They built simulations. Every known ancient method was modeled. Rollers, ramps, levers, counterweights, pulley systems, human labor at absurd scales. They were generous, far more generous than reality allows. 10,000 workers, 20,000, 50,000. Ramps with ideal friction coefficients. Rollers that never splintered. Ropes that never frayed. The AI ran thousands of scenarios. Every single one failed. Sometimes the rollers crushed under load. Sometimes the rope snapped. Sometimes the ramp collapsed under its own weight before the stone moved more than a few meters. In the best-case scenario, the stone advanced centimeters per day, until one minor failure reset months of progress. At that pace, moving a single block from quarry to platform would take years. The trilithon isn't one block, it's 3. And they weren't the only megaliths on the site. One engineer, writing anonymously in a European engineering journal, summarized the conclusion bluntly. We designed the models to show how it was done. Instead, we proved it couldn't have been. That sentence never made it into a public report, but it spread, quietly. Then the AI examined the abandoned 650-ton stone, and that's when the question changed. Because no structure at Baalbek could even support a block that size. No wall, no platform, no temple. It was functionally useless, unless the act of cutting it was the point. The AI flagged it as an anomaly, technically achievable, structurally unnecessary, which raises a terrifying possibility. What if the builders weren't solving a construction problem? What if they were testing a capability? If this story is gripping you so far, take a second to like the video and subscribe to the channel. It signals to the algorithm that long-form, thoughtful content like this matters, and it helps this series reach people who are asking the same questions you are. Because once the team realized Baalbek wasn't unique, everything escalated. The moment the team stopped treating Baalbek as an isolated anomaly, the entire narrative collapsed. Up until then, the site could still be framed as an exception, a strange outlier, a one-time engineering miracle lost to history. Archaeology is comfortable with anomalies because anomalies don't demand rewrites. They can be boxed, labeled, footnoted, and safely ignored. Patterns are different. Patterns force questions. So the researchers did something deceptively simple. They expanded the dataset. They fed the AI information from other megalithic sites around the world. Not folklore, not myths. Hard data, measurements, stone weights, tool marks, astronomical alignments, erosion profiles, construction geometry, the Great Pyramid, the Sphinx, Göbekli Tepe, Pumapunku, Sacsayhuaman, Stonehenge, Karnak, Yonaguni, sites separated by oceans, by languages, by thousands of years of supposed cultural isolation. The AI wasn't looking for identical techniques. That would have been naive. Different stone types require different approaches. Different climates leave different marks. Instead, it searched for structural logic. recurring decisions that didn't need to be made but were made anyway. And that's where the first global pattern emerged. Latitude. Megalithic sites clustered around very specific bands on the planet, not randomly, not evenly. The densest concentrations appeared near 30 degrees north, 34 degrees north, and along the equator. Baalbek sits at 34 degrees north. So does the Great Pyramid's internal geometry. So does Jerusalem's Temple Mount. The probability of that alignment occurring by chance was calculated at less than 2%. Then came orientation. Many of these sites align with solar events, equinoxes, solstices, but not in the casual, approximate way often assumed. The margins of error were often less than 1 degree, in some cases, less than half. Achieving that precision without advanced instruments is not impossible, but achieving it repeatedly, across continents, across millennia, begins to look deliberate. The AI flagged a second pattern: stone size selection. In many cases, builders chose stones vastly heavier than necessary. Structures that could have been built using 10-ton blocks instead used 50-ton stones. Walls that could have relied on stacked masonry instead incorporated monoliths weighing over 100 tons. From an engineering perspective, this makes no sense. Larger stones are harder to quarry, harder to transport, harder to place. They increase risk without increasing structural necessity. Unless size itself mattered, unless mass was not a byproduct, but a requirement. The AI then examined angles, and this is where human intuition tends to fail. Certain angles reappeared across unrelated sites: 23.5 degrees, 51.8 degrees, 19.5 degrees. These numbers aren't arbitrary. They relate to Earth's axial tilt, to geometric stability, to resonance patterns in three-dimensional forms. Engineers recognize them. Physicists recognize them. Ancient myth never mentions them explicitly, yet they appear encoded in stone, again, and again, and again. At this point, coincidence stopped being a reasonable explanation. Then came the age estimations. Dating stone is notoriously difficult. You can't carbon date rock. Instead, you analyze weathering, microerosion, lichen growth, chemical alteration, surface rounding, and you cross-reference it with climate history. The AI did exactly that. Göbekli Tepe, already officially dated to around 9600 BCE, returned probability clusters suggesting portions might be older. The Sphinx, long controversial due to water erosion patterns inconsistent with Old Kingdom Egypt, returned estimates pointing to a much wetter climate, one that existed thousands of years earlier. Yonaguni, dismissed by many as a natural formation, showed tool signatures classified as artificial, combined with submersion depths that imply construction when sea levels were dramatically lower. And Baalbek. The trilithon stones did not weather like Roman masonry. They weathered like something far older. The AI's median estimate placed their construction around 9,000 to 10,000 years ago. That date is devastating. It predates writing. It predates metallurgy as we understand it. It predates agriculture in much of the world. It predates civilization, at least as history defines it. The researchers stared at the output in silence. Because if the AI was even partially correct, then human history wasn't missing a chapter. It was missing an entire volume. But the most unsettling result was still ahead. When the team cross-referenced construction timelines with paleoclimate data, another pattern emerged, one that no one had asked the AI to look for. Major megalithic construction phases clustered just before periods of global disruption. Göbekli Tepe was built at the end of the last ice age, just before rapid warming reshaped ecosystems worldwide. The alternative dating of Giza aligns with dramatic sea level rise that drowned vast coastal regions. Other sites peaked before prolonged droughts, volcanic winters, or regional collapses. Build big, then collapse. Not during the building. After, as if the monuments were final acts. Last statements carved into stone by civilizations that sensed something coming. The researchers began referring to it privately as a cycle. Expansion, monumental expression, disappearance, the Baalbek pattern. It never appeared in official papers, but it circulated in emails, in late-night conversations, in the quiet spaces where scientists admit uncertainty. Someone finally asked the question that shifted the room from academic curiosity to existential dread. What happens if we run the model on us? Modern civilization has never built heavier, never taller, never faster. We extract more resources in a year than ancient cultures did in centuries. We reshape landscapes. We alter climate systems. We stack complexity on top of complexity and call it progress. The AI did not predict the future, but it did something worse. It showed precedent. And precedent suggests that civilizations capable of monumental construction often mistake permanence for invulnerability. The stones of Baalbek have already seen this story play out multiple times. They remain. Everyone else vanishes. Once the idea of a lost capability entered the room, it refused to leave. Engineers don't like mysteries. They tolerate them only until a better model appears. So the next phase wasn't philosophical. It was brutally practical. If ancient builders really did move and place stones weighing hundreds, possibly thousands of tons, then the question wasn't who or when. It was how, in terms that obey physics. Because physics does not care about mythology. The AI was instructed to do something radical. Ignore cultural timelines entirely. Forget Romans. Forget Sumerians. Forget labels. Instead, assume a human civilization with access only to natural materials: wood, stone, fiber, water, gravity, and ask one question: what methods could theoretically work? Not comfortably, not efficiently, just work. The first candidate was counterweight engineering. Simple in principle. Use mass to move mass. Large-scale counterweights can generate enormous lifting force if designed correctly. Water-filled chambers, sand reservoirs, dynamically shifting loads. The problem isn't the concept, it's the scale. To lift an 800-ton block, even a few centimeters, you'd need counterweights of comparable mass. That implies infrastructure on a level we've never found. Massive containment systems, channels, valves, control mechanisms precise enough to prevent catastrophic imbalance. No remains of such systems exist at Baalbek, unless they were dismantled completely. Next came hydraulics. Fluid pressure can amplify force dramatically. A small input force applied to a sealed system can lift enormous loads. The principle is ancient. Even primitive cultures understood water pressure intuitively. But implementing hydraulic lifting at this scale requires airtight seals, pressure-resistant containers, and a deep understanding of fluid dynamics. Again, no evidence. Then came vibration. This is where the room divided. Certain frequencies can reduce friction. Acoustic resonance can cause materials to behave differently at contact points. Even today, vibration-assisted machining allows cutting and polishing that would otherwise be impossible. There are ancient legends across unrelated cultures of stones being sung into place, of sound used as a tool, of builders who understood resonance rather than force. The AI didn't dismiss this outright. It modeled it. The results were ambiguous. Under specific conditions, vibration could reduce effective friction enough to make movement plausible. Not easy, not trivial, but not impossible. The problem? you'd need precise control of frequency, amplitude, and synchronization across massive stone surfaces. That implies instrumentation, knowledge, training, none of which leaves obvious archaeological traces. And then the AI proposed something that unsettled everyone. What if the technology wasn't complicated? What if it was systemic? Instead of one miraculous device, imagine a culture optimized around movement, mass, and coordination. Imagine knowledge passed through apprenticeship rather than writing. Imagine techniques so embodied that they didn't feel like technology at all, just the way things are done. When that kind of knowledge disappears, it doesn't fade. It collapses, because no one remembers enough to rebuild it. This would explain something that has always bothered archaeologists: why advanced capability appears suddenly and then vanishes completely. There is no gradual decline at Baalbek, no smaller stones, no sloppier cuts, no reduced ambition, just abandonment. The unfinished blocks in the quarry aren't evidence of failure. They're evidence of interruption. Climate data offered one explanation. Around 10,000 years ago, Earth underwent violent, rapid changes. Temperatures spiked, ice sheets collapsed, sea levels rose more than 100 meters in a geological blink. Civilizations dependent on coastlines would have been annihilated. Trade networks shattered, populations scattered. Specialized knowledge, held by a small number of experts, would be lost almost instantly. Survival doesn't preserve craftsmanship. It discards it. But there's another interpretation. One the AI couldn't confirm, but couldn't ignore. What if the builders stopped intentionally? What if the unfinished stones weren't abandoned in panic, but left as a decision? Large-scale construction reshapes societies. It concentrates labor. It consumes resources. It alters ecosystems. At some point, the cost may exceed the benefit. Modern civilization understands this better than it likes to admit. Mega projects don't fail because they can't be built. They fail because they destabilize everything else. The Baalbek builders may have reached that threshold and stepped back. If that's true, then Baalbek isn't a monument to power. It's a monument to restraint or to regret. Standing among the ruins today, that possibility lingers. Archaeologists describe an unease they don't feel at other sites. There's no triumph here, no sense of clever ancestors outwitting nature. Instead, there's a feeling of interruption, as if the story wasn't finished, as if it was deliberately left open. Local guides, whose families have lived in the valley for generations, don't speak in technical terms. They don't need to. Their stories are simpler and perhaps more accurate. The stones were here before everyone, one guide says. They will be here after everyone. There's no mystery in his voice, just acceptance. Children play near the platform. Families picnic in the shadow of blocks heavier than modern machines can lift. Life absorbs the impossible and keeps moving. Maybe that's the final lesson. Civilizations rise, build, and vanish. Stones remain. And perhaps the real warning isn't about lost technology. It's about how easy it is to forget that progress is not the same as permanence. What makes Baalbek unbearable to think about isn't the engineering. It's the mirror. Every civilization believes it is the first to reach the edge of possibility, the first to master nature, the first to understand the world well enough to control it. The builders of Baalbek likely believed the same. They stood where we stand now, at the peak of capability, surrounded by tools that felt unstoppable, convinced that their knowledge marked a permanent step forward in human history. And then something happened. The AI doesn't speculate. It doesn't moralize. It doesn't tell stories. It only compares. And when modern data was introduced, resource extraction rates, energy consumption curves, climate feedback loops, infrastructure dependency. The similarities were impossible to ignore. Civilizations don't collapse when they are weak. They collapse when they are maximally efficient. When every system depends on every other system. When redundancy disappears. When complexity becomes fragility. The Baalbek pattern doesn't predict an apocalypse. It predicts something quieter. Forgetting. When systems fail, the first things lost aren't monuments. They're specialists, engineers, craftsmen, the people who understand how things work, rather than just that they work. Within a generation, complex knowledge becomes ritual. Within 2 generations, myth. Within 3, fantasy. Imagine our world without electricity, without digital storage, without global logistics. How much of what we know would survive? The AI highlighted something else, something almost cruel in its simplicity. Stone remembers. Civilizations don't. The trilithon blocks don't tell us how they were moved. They don't explain themselves. They don't offer instructions. They only demonstrate that someone once could, and that no one since has. That realization has quietly reshaped how some researchers view the site. Baalbek is no longer treated as an engineering puzzle to be solved. It's treated as a boundary marker, a line carved into time that says, "We reached this point once before." The Roman temples on top of the platform are symbolic in a way no historian intended. A later civilization, proud and powerful in its own right, built atop something it did not understand, assuming continuity. Rome fell too. Not suddenly, not dramatically, gradually. Knowledge thinned, systems simplified, capabilities narrowed. By the time medieval builders passed through the valley, the stones were already ancient beyond memory. Today, Baalbek exists inside a fragile modern state, struggling with debt, power shortages, political paralysis, and social strain. The contrast is almost unbearable. A civilization capable of placing 800-ton stones with millimeter precision once existed here. Now, keeping the lights on is a challenge. And yet the stones remain untouched. They don't care who rules the land. They don't care about ideology. They don't care about progress. They simply endure. Perhaps that's why Baalbek unsettles people who truly study it. Not because it hints at lost super technology or ancient geniuses, but because it strips away our arrogance. It suggests that advancement is not linear, that forgetting is as natural as discovery, and that monuments are not always celebrations. Sometimes they are confessions. If Baalbek is a message, it isn't about how great the builders were. It's about how completely they vanished, and how easily we might follow. If this story made you stop, think, or feel even a fraction of that unease, like the video and subscribe to the channel. Not for the algorithm, but because these questions matter, and they deserve to be explored deeply, not reduced to sound bites. There is more beneath the surface of history, and the stones are still waiting.